Welcome to this afternoon's session. So we're very honored to have 4 very successful data science startup business folks here. So quite an accomplished panel we have here. So the first question I have is a pretty simple one. So we all know data science is hard. AI data science. To become a data scientist is very difficult. To be an expert in AI is very difficult. You heard from a lot of startup folks here yesterday how startups are very difficult, right, to have a successful startup business. So now you have to combine the two. You have to combine a startup with AI and data science. So as accomplished practitioners, if I can say that, what were some of the biggest challenges you faced in setting up your data science business, and how did you overcome those challenges? Kana-san.
日本語でごめんなさい。うちの会社はデータをお客さんからデータ預かって分析のサービスを提供する会社をやってるんですけど、僕の会社では昨日もちょっとだけ話しましたけど、やっぱり一番ハードルが高かったのはその仕事を会社で利益出せるだけの仕事を受注するだけの分析官のスタッフの組織を拡大させることと、その組織分食わせるだけの仕事を取ってくるっていうところの2つが難しかったですね。で、特に今でも苦労してるのはその分析を仕事を取ってくる営業を育てるのが分析官自体を育てるより今は難しくてですね、分析人材は一定規模集まると新しい新卒の人とかを採用してもプロジェクトにアサインしながら教育ができるんですけども、お客さんがその僕らの抱えているスタッフで解ける問題で価値を出せる仕事をきっちりと取ってくる営業っていうのがですね、いまだに難しくてですね、この営業の数がうちの会社の成長の一つのボトルネックになっていて、いかに営業させるかっていうのが今でも大きな課題です。
Would anyone else like to take that question?
So basically, this is not gonna resonate with Japan, but failure. You fail 3 times and your 4th one's successful. So I've been doing startups since I was 19. I'm now 27. So I did startups in the Midwest, trying all sorts of crazy business models. But I was focused on being a developer, and I had to kind of transition to being able to do sales. I learned how to do sales on my own. I did my own sales and my own coding. So if you have any kind of lessons from me, it's persistence is key, and also location. I co-founded my company in San Francisco, and I would never do it anywhere else in the world. You know, I moved to Japan now. I live in Tokyo, and comparing the 2 ecosystems, I don't think I could co-found a company here. I have one here. I love it here, but you need an innovative ecosystem. I started my company in the Midwest and moved to San Francisco, and that's where we got our funding. That's where we started really succeeding. So you need a network, and you need to be able to go out there and talk about what you do to the right people. The right people are in Silicon Valley. If that makes sense.
Ingo, would you like to answer that question?
Sure. 3 failures, I think it's probably more like 300 failures, but that's still okay. If the 301st time is actually really, really good, that still can be a success. I think it's a very normal thing. I agree on the ecosystem part, but overall I would like to add that it's not different in the data science space. Yes, it is a complex space, but building a company, founding a company, growing a company is not that much different in the data science space than anywhere else. You have the same challenges. It might even be, maybe that might surprise you, even easier because data science is so complex, it's so difficult. The resources are so scarce, the problems are so big, but the values you can generate are much larger than for many other problem types. So that actually you can sometimes solve something very little, very small, and focus on just solving that. And that has still a lot of value for your clients, and it makes it so much easier for you to focus and sell this one particular solution. So one side of me would say, like, yeah, you need to deal with both complexities, but actually the complexity of data science is also full of advantages. So I think that's actually a good thing to exploit.
Lukas.
So yeah, so I mean, I would really agree with that. I think that for a startup where there's a difficult thing, there's an opportunity because startups can be so much more nimble than a bigger company. So I think the fact that data science is difficult makes it a real opportunity for startups to succeed against bigger companies and bigger competitors. And so I would even say, I think founding a company outside of Silicon Valley, there's certainly a lot of challenges, but there might be a lot of opportunity there because, for example, the Japanese market might have less competitors for a data science company. So I think actually as a startup, it's probably good to look for certain types of challenges where you can carve out your own niche and create an advantage.
Right, very insightful. Adam, you mentioned failure. So I guess a hard question is, why do so many data science projects fail?
So I would say many of them are just focused on hype. So a lot of data science is filled with expectations that are not realistic. If you look at the hype today, people think machine learning can do everything. People equate machine learning with general artificial intelligence. And it's really not. It's pattern recognition. It's counting things, right? And I think people expect miracles when in reality you really can't do that. So if you set the right expectations and the right deadlines, and have the right people, and go in with the right ideas, and by setting those ideas being, let's start with a small milestone and work our way forward, then you can kind of build something successful. But most people just jump in headlong and don't, head first and don't really, they fall on their head. They don't think about, they move too fast, they have too many expectations. So if you can coordinate that, I think you'll be fine. One other, I guess, finishing this off, data scientists only think about building models. They don't think about the business context as well. So think about the business context when you're figuring out a problem to tackle as well.
I see both, actually. I see this type of behavior that people jump into those projects, and it's often driven by IT more so than the business side, because there is just a new hype, there is a new model type. Just think about deep learning, your area right now. I think you will see this every single day. It's just the latest and greatest. By the way, it's not that latest, but that's only for the people who know this field for a long time. But right now, for the business side, for the IT side, it's just the latest thing. Let's just do it because it sounds so great. Yes, I see that, and that often fails because people didn't even think about if that's actually even the right solution for the type of problem I have. On the other hand, I see very high expectations. It's almost driven in a more traditional sense, like, oh yeah, other maybe competitors are doing something, or here's a good idea which worked in a certain field, let's deploy this idea now somewhere else. And then all of a sudden what begins is a very traditional, almost like a waterfall model of defining targets and how to approach the whole problem and how to collect all the data. And now this whole thing is turned into like a 2 or 3 year project, which takes way too long, where in 80% of the time people re-implement, develop source code, which actually wasn't even necessary because in a version of this was already existing. So it's all of a sudden blown up to this massive project. And that also adds to the wrong expectations. I think the truth should be somewhere in the middle, like we see in software development as well. Nobody is developing new software today in a waterfall model any longer. So it's an agile process, you make short iterations, you get to quick results early, and if after, let's say, 1 or 2 sprints of like 2 or 4 weeks, you realize this is not leading anywhere, okay, that's also a failure, but it's a fast one. So let's fail fast, move on, do something different. So set the goals for a reasonable time frame, like 2 weeks, 4 weeks, and then get to some success at this point. And if there's no success, move on, do something else. And that's an approach I would like to see more often, but I see both extremes. Let's just do it and work for this for years, or let's plan it for a year before we even start. I think both approaches are actually wrong. So
one of the reasons I'm sitting beside Ingo is if he talks too long, I'm supposed to kick him. But he always had too much caffeine, so he's... But very good answer. Kusano-san, you're very active here in Japan. Do you have a thought on that question?
先ほども成功のキーが営業っていう話をしたんですが、営業の仕事って本当に仕事を見つけてくるってこともそうですが、もう一個は本当にお客さんとの期待値調整とか、 その取ってくる仕事ってただ発注もらえばいいわけじゃなくて、その分析サービスを提供したときに、ちゃんとお客さんのビジネスで価値が出せる仕事を見つけてくる、あるいは本当にお客さんの、なんか受け答え見てて期待値が大きすぎればこう下げ、そんなことはできませんよという話をきっぱり言いながら、でもここはできるんでやらせてくださいとかですね、あるいはもうちょっとお客さんとうまく回せるか自信がなければ本当にフェーズを細かく切って、こういう分析まず最初にやって、これができれば次はこういうことが分かれば次こういうことも多分できるんでということで、割と細かくフェーズを切るという形で僕らはですね、リスクを調整してお客さんとリスクをうまく分け合いながら仕事を進めていきます。でそれで仕事の成功率を上げることで、会社としても儲けながらビジネスを伸ばすってことをやってきています。あとは本当 B2B のビジネスになりがちなので、ここは本当にセールスマンが良ければ仕事をやっぱ見つけやすいと。なんか B2C みたいにプロダクト出して当たるかどうかを待つよりは、いいセールスマンがいればきっちりと仕事はしかるべきところに行けば、なんか課題はあるので、それがお客さんは分析で解けるとは思ってないだけで、それをちゃんとデータがあればこういうことができますよってことをやっていけば、ニーズは掘り起こすことができるんですね。そういう意味で本当にいいセールスをマンがいることがすごい重要なんじゃないかなというふうに思っていますし、それによって僕らはそのビジネスのリスクを下げて、できるだけプロジェクトの成功率を上げているっていう実態が今あります。
Very true. I actually had to smile when Ingo was talking about agile development in data science, because we know a lot of data science projects, they're kind of like research projects, right? You're not quite sure how your models, your feature selection is going to work, your outcomes and all that good stuff. And that actually reminded me of a blog post that Lukas wrote, I think it was last year or a while ago. But we've all heard, and you've heard this phrase a million times, how data science is the sexiest job of the 21st century. But Lukas here said that actually we spend most of our time being data janitors, because no one ever thinks about cleaning the data and the work that goes into marshalling your data and getting it right so you can run your data science projects. So you guys are in the business of data science, and Ingo, you already alluded to it, but how do we speed up data science and AI so it operates at the pace of business? Because you don't want these projects running 6 months, 9 months, a year with no outcome. That's what gives data science and the business of AI a bad reputation, that you start off with this big promise, 3 months, 6 months later. So who would like to take that question? I'll just open it to.
I just have to, because I think in general, most data science projects, practically all of them, fall into 3 phases. The first phase is what I call the prototyping phase. In that phase, you still understand the data, you enrich the data, you generate more data if you need to. And that's often typically where most of the implementation of the data science processes, workflows, models actually happen. The next phase I call the substantiation phase. Now you have kind of candidates for things which might work, but now you use those models, for example, you created machine learning models, for example, on larger data sets, maybe on all the data you have, and to prove it's still feasible and it still works as good as expected. And then the last phase is what I call the operationalization phase. Now you take the best model, which you have been proven to be good and fast, in the substantiation phase and put this actually into production use. And then there's kind of like a hidden 4th phase, which is maintaining this model and making sure it stays good and works. And if you really think about where people spend most of the time, it's actually the very first phase and the prototyping phase. And there's 2 reasons for that. First of all, because if a project fails, it fails then already. So it doesn't even get to the other 2 or 3 phases to begin with. But the other point is that's where most of the data preparation happens, which takes a lot of time, because that's really the hard problem. It's not to pick or tune the model. That can be completely automated at this point. It's actually about getting the data into the right format. That often requires human intervention. That's kind of like a human-computer loop. So a little bit of creativity comes into this, and that I want to keep. What I don't like to do is actually spending time on recoding the same stuff you or one of your colleagues already did last week, that you solve standard problems in data engineering over and over again by writing R or Python scripts. And then even if you do this, you're not sharing them with the rest of the world, so nobody else can benefit actually from this knowledge which is hidden somewhere on your computer. I think if we are smarter in speeding up this prototyping phase, this is where the biggest gains are. And this is also where we see also in the own customer base, that's where people really get more productivity if they actually are a little bit smarter, use coding only where you solve something for the very first time, but then you reuse standard solutions whenever you can, actually. And I think that's a very smart thing to do to begin with. I, unfortunately, in data science don't see this because most people still act like researchers, and that's fine. It's just not effective. And as a business, you need to know if you want to fund that science or not.
All right. Lukas, do you have any thoughts on that?
Well, you know, I think one thing that's surprising is if you ask data scientists what they spend their time doing, they say 80% of their time is spent cleaning data. And you know, when you're in school, you don't really learn to clean data. It's not a topic that's really addressed in school, and so you're taking a very expensive resource, maybe BrainPad, you know, and probably your employees are mostly cleaning data too. And I think it's rational because the most important thing is clean data. So if you have a beautiful analysis on dirty data, it's worthless. I'd much rather have a simple analysis on very clean data. So I think it's good I think it's rational that people spend their time cleaning data, but I think the thing that's most surprising to me is that most data science companies, most data science startups, they're about the 20% of the time, the algorithm and the sort of like really complicated parts. But I think there's not enough tools for the 80% of the time.
Yeah, excellent points.
But I think part of the solution is how do you automate this part? So when I said before, like there's human work involved there, and I want some human work involved when creativity is needed, because that's where computers right now are pretty lame. So we are not really, we have no way that our computers can come up, for example, with new features describing the world, new ways how your data could look like. This kind of creativity is very hard to automate. After you had the idea, you still can automate the process to transform your data. And I think that's the key. So how can you transform processes but still allow somebody to employ some creativity? So I wouldn't even like the idea of a product where it's just like, okay, feed the data in, press one button, and then magically data comes out, and I can't even change it. So I would like to...
I would buy that product.
Good, but I'm not sure how many data science projects you're working on. So like if you saw them often enough, I don't know, it's really the best results I got has not been from the best models or the best tuned parameters or the cleanest data. It was actually where somebody had an absolutely brilliant idea to add a couple of additional columns, getting closer to what really the underlying problem is you want to model. And this kind of creativity, I think, that's something where we have some advantage. Computers can help, processes can help, but often it's really this one idea where I really think like, okay, how on earth did you come up with this brilliant idea to generate this additional column? Okay, but it was doing the trick.
So I think one question is very important for our audience because many of you here are AI and data science experts or becoming AI and data science experts, and you know you're in the business of selling AI and data science or buying it. But we all remember the financial crisis, right? That was a great example of black box models run amok. And we're kind of in an interesting state now because there are companies out there who are still selling black box models, so to speak. We're in a much more open world. But also, think about it. When you go into a company and you're trying to explain an AI or a data science model, if the people sitting across from you don't understand that, if you start talking about deep learning and bragging how many hidden layers your deep learning model has, like, they can nod their head, but you think they're going to put their career on the line, they're going to put their company money on the line. So how does, in the business of data science and AI, how do we deal with this black box problem? Adam, do you want to take that one?
Sure. So I sell open source black boxes.
What is that?
Yeah. So yeah, exactly. Right. So so you have to my point, you have a lot of tools for doing deep learning and all these other things, but there's no focus on understanding what's going on with the data. And predominantly one of the problems there is you have a big focus on algorithms, and it's actually the same problem companies run into. They're spending most of their time talking about the 20% of the product, the product and the, building models and actually building something useful for people. So all I can say about addressing the black box problem is human in the loop AI. So one of the things we do, we sell a lot of deep learning stuff, and we predominantly do fraud detection and things of that nature. And but we focus on having the neural net point at things. So one of the things we do is we basically use black box models to assist something else that then actually acts or be creative or what have you. So if you can pair a black box with something, then and still benefit from more accuracy, I think you're in a relatively good position.
Kana-san, do you want to take that question also? Or not? How about Lukas?
やっぱり人間参加は大切ですね。I think it's a really difficult problem. I think black boxes. Can they translate black boxes? Is that black box? Wakaru? Okay, black box. So I think black box is incredibly dangerous. I think black box led to our financial crisis. I think it leads businesses to have lots of problems. I think one thing I try to do with my company's tool is make sure that it's not. We say we don't want a black box, we want a toolbox. We think that's super important. So,
excellent. And I think another important question that I'm sure the audience would like to hear your answers on. Each of you guys run your own companies. You see a lot of clients using AI and data science to gain competitive advantage, right? Otherwise, they wouldn't be engaging with you for one degree or another. So I guess this is a double-barrel question. How are you seeing companies across different industries, whether it's finance or healthcare, manufacturing, education, how are they using data science and AI to gain competitive advantage? And a follow-up question from that is, how much trouble are companies who don't do that in if they're not using AI and data science? Like, at what point, and I know it varies by industry, but at what point will they start to get into trouble? So whoever wants to.
I could take it if.
Yeah.
So one thing we saw a couple years ago is e-commerce companies, or not even e-commerce companies, but retail, realizing that they needed to do data science because, when they improve their relevance, they improve their revenue. And we watched some real retail companies like Walmart did a really good job of kind of moving into e-commerce, and their stock price reflected that. Whereas other companies did a really bad job and actually really struggled to hire data science teams, like JCPenney, which is almost bankrupt at this point. So I think e-commerce is a good example of how essential it is for companies to figure out how to do data science. I think a really good example that's happening right now is automotive companies suddenly need to understand data science well. And I think the car companies that learn to do data science, because they need to collect data from sensors in all their cars. And if they figure out how to do that, they will survive. And I think if they don't figure out how to do that, they might have the same fate as the American retailer JCPenney.
So I guess one industry that I'd want to hit, just because we see a lot of business there, is telco. Telco right now has the danger of being commoditized. This idea of a dumb pipe. If they don't focus on technology, they don't and focus on leveraging the data that they have to build a better experience for their customers. Then you run into this problem of, well, what do we do down the line if there's usually a monopoly of some kind with telco, right? What happens if that monopoly goes away? What happens if real competition comes in? What do you do then? So that's why you see a lot of telcos kind of diversifying across various verticals. But then they don't know what to do with that data. So So if you can find, so what they're doing is they're creating new revenue streams. They have their own TV products or what have you. And they're recommending things to customers, things of that nature, right? Like so if you need to figure out what they need to figure out what to do with that. Otherwise, they're going to be commoditized. And the ones that are not embracing that are, they're going downhill.
どんなビジネスをやっているかにもよると思うんですよね。差がつきやすい、そのデータサイエンスを採用することによって差がつきやすい事業と、割とその差がつきにくい事業、つまりなんかあまりそもそもデータを取っている会社が他にもいない全業種、その業界の中で誰もこうちゃんとデータに向き合ってないような業界とかは多分そんなに簡単には差がつかないというかだと思うんですが、本当に今話が出たみたいなその EC とかネットが絡むようなものは本当に簡単に差がついて、でそのうまく活用したことによってユーザーのエクスペリエンスを高めることができるので、よりお客さんが集まってイコールよりデータが集まってよりいいサービスが提供できるサイクルが回せると思うので、まずそのネットに絡んでいるところはもう本当に使ってないところはどんどん差がついちゃうというところはもう間違いないと思うんで、本当今後は本当に IoT 等々でこれまでそのデータが取れなかったからあまりデータサイエンスが活用できなかった領域がまさにデータを収集すること、戦略的に収集することでサービスを作り出せるっていう時代が来るんだろうなというふうに思っているので、そこではまたこれまでそのデータサイエンスで競争優位がつけなかった領域がこの IoT とか AI みたいなそのリアルタイムに分析するスキルというか技術が上がっていくことで、今後どんどんその競争される領域がどんどん増えていくんだろうなというのは思ってます。なので今後そういう、そこに採用できなかった会社、Amazon、例えば Amazon Go って小売りで新しいビジネスモデルだと思うんですけど、あれも本当に AI とセンサーの塊みたいなビジネスモデルで、あれがユーザーにどこまで受け入れられるかはまだ分かりませんが、ただあれもし本当にできちゃうと、でそれを受け入れられた時は本当小売りはあれに対応できないともうお客さんが来ないっていうふうな状況になってしまうと思うので、ああいう形で本当に革新的なビジネスモデルがまだまだいろんな領域で作れると思ってますので、そういう意味では今アクションを作って考えていくっていうのはすごい新しいアイディアをどんどんいろんな業種にぶつけていくのが、僕らは楽しみだなと思って取り組んでいますし、そこでなんかある業界のすごいゲームチェンジャーを作り出すことで、僕らもそこが成功すれば僕らも潤うっていう状況を作っていきたいなという感じで思ってます。
So before we take a question from the audience, Ingo, do you want to? You've got a few words now, don't you?
I promise it's going to be short. It's only 2 words, really. The question, which are the industries which can benefit from data science? The answer is very short. It's all. And when? It's now. And really, there's no excuse. And I mean this. And I don't want to sound like it's crazy and oh my God, panic. If you don't act now, we are all doomed. That's not my point. The point really is, people underestimated so many changes. They underestimated, for example, the internet to begin with, like especially retail. Like all of a sudden, like, oh yeah, this all online business, who's needing this? And the companies who haven't been at the forefront making a change, they're all gone by now and have been either replaced by new companies or the other companies have been winning where the companies which actually have embraced the trend there. It's the same on data science. You might not feel it's necessary now because all your competitors are not doing this. But on the other hand, you can get an advantage. Why would you not take this advantage? You take every other advantage you can get over your competitors as well. So it's a little bit crazy, actually, that sometimes people believe, like, yeah, I don't know. You can wait a little bit because others are not doing this. No, now is the time. Now, not tomorrow, now.
Excellent. I have about 50 more questions, but I would love to take a question from the audience if someone wants to ask a question. Otherwise, we have one down there. Do we have a mic, or did I just throw that out there?
Hello. Yeah, since we talked about data, machine learning, and also the financial crisis, I want to just add some comments here. I know about the financial crisis because I work for Lehman Brothers in that year. First thing is that we need to understand that there are certain things that data and models cannot do. And that distinction needs to be very clear. In that year of 2008, we had absolutely no clue with all our data, all our models, and all our analysis that Lehman Brothers will not exist by the end of the year. It was not because we were stupid or dumb, but if you tell somebody in the end of 2007 that the spreads between the treasury rates and the overnight index swaps can go from 10 basis points to 370 basis points, people will laugh at you. If you tell people a trade and a hedge, and between them, what is a correlation, it can be extremely dynamic in the next 1 year, you would have been laughed at. The point I'm trying to make is that, at least in the financial industry, stuff or black swan, what do you things you call it, they happen, which we call as low frequency, high intensity events. And they happen at a scale which is far beyond the normal noise that happens maybe for some other industries. There was nothing between 2000 to 2007 in a benign interest and thing that could have caused us to believe that something of this magnitude can happen.
Do you have, and so the question around that is
that data is very seductive. Past data for the last 1 year or 10 years, we should be not so seductive or impressed by the data and belief in our models to trust too much.
That's
in
a
this
good question. Ingo, do you have a?
Yeah, absolutely. I think there is a huge difference, and if I would need to bring it down to one sentence, I would probably use the one Andrew was the chief data scientist at Baidu was recently coining. Where are models, where is predictive analytics, where is machine learning really strong? It's strong for everything you can solve as a human being in less than a second. So, meaning, think about the sentence for half a second. That means if you can actually grasp the current situation in less than a second, if you can make a decision in less than a second, and maybe if you even can act in less than a second, that's something you can fully automate by now by machine learning, and often you're better than human beings. The falling of Lehman Brothers, the whole financial crisis, is this something we would call it's a problem we can solve in less than a second? No, it took us 8 years, and some believe it's still not fully solved. So is this a problem machine learning can do anything useful about? Well, it can definitely give you some pointers, outliers, indicators. Sure, some people might actually have been finding them. But is this something where it's actually providing a lot of value? And I would clearly say no. Machine learning has biggest value if you can automate not one big decision, if you're not predicting this one single big event, which is this low frequency, high impact event, but if you actually can automate the decision making of 5 or 50 or 500 million decisions every day. And every decision might only give you $1 profit. But if you do this 5 million times per day, you will still get a lot of value out of this. And I think that's really the demarcation. This is really the line, the separating line between where is modeling, where is machine learning good, and where is it not so useful. It's really along this line, can you as a human being make this decision in a short amount of time based on the information you have? That's where machine learning is actually strongest. And this might change. Maybe in 10 years from now, this time frame is no longer a second, but 10 minutes. But I think right now, a second is a pretty good estimator for that power we talk about.
Absolutely. I would love to take another question, but does anyone else want to answer that before we try and squeeze in another question?
Well, I guess I kind of disagree. I mean, I think that machine learning is only as good as the operator. Like, I think there were some folks that predicted the financial crisis and made quite a lot of money off that prediction. And so, you know, I think where models go wrong, it's because people use the models incorrectly.
I absolutely, it was John Paulson who made a lot of money in that, and I second that. Lukas, so one more question, I think, or maybe two.
It was very interesting that e-commerce boom or .com bubble made existing retail players to face data science mind, and new data-oriented startup achieves super growth in such opportunity, and now car manufacturers are forced to do that. And from your perspective, which existing industry looks the most interesting to installing data-oriented operation in this point?
So actually, something that hasn't been hit large scale yet is manufacturing. So if you can hit manufacturing and logistics, there's a lot of things you can actually optimize for. So I would say always look, as far as the greatest opportunity goes, look for the principle of least presence. Like where is it least present? Go there and automate it. It's the same principle of every company is going to become a software company. Every software company will become a data company. It's just a matter of when and progression.
Got a question? Anyone else got a question? Got 1 minute left. Kusano-san, for that last question, do you have an opinion on it, since we have some time, for the Japanese market?
僕の体感値としてはですね、本当に日本の企業は今本当にその AI って言葉でこう経営者もなんかやんなきゃまずいんじゃないかと、昨日も話したんですけど、ビッグデータって時は結局この国の経営者は動かなかったんですね。で多分アメリカはその時もずっと動いていて、多分さらに生産性を上げるってことができてたと思うんですが、日本の企業はこの5年6年はビッグデータってことをキーワードには動けなかったっていうのが僕の印象です。この13年間やっててですね、多少問い合わせは増えましたけど、それでもなんかものすごく問い合わせの内容が深度が深まったかっていうとそんな感じもなくてですね、なので少なくとも僕の体感値としては、もうあらゆる会社がこれからやんなきゃ、で猛スピードで追いつかなきゃいけないっていう状況なんじゃないかなっていうのが僕の認識です。その中でもやっぱ自動車会社さんとかは本当に分かりやすい脅威というか、この自動運転にちゃんとキャッチアップできないとマーケットなくなっちゃうかもみたいないう危機感があるので、やっぱりなんかもう以前とは違う形でですね、自動車会社さんから問い合わせなんかなかったんですけど、今は僕らもなんかいろんな形でお話を聞くような機会とかが急に増えてたりとかしているので、そういう意味で言うと車会社はすごく火がついているような気がします。
So I think we're out of time. Kusano-san, Lukas, Adam, Ingo, thank you very much for being very good sports and participating in today's panel. Thank you.